sigma e squared, which is 0.002 squared. So we plug in those numbers and then we solve for sigma p. Now sigma p equals, we use Excel square root function directly, so SQ RT 0.003 square subtract 0.002 square. So we got sigma p equals this 0.002236068. So we can reduce the format cells, reduce the number of decimals. So number, I only need 3 decimals, maybe 4 decimals here. So 4 decimals. So this is the standard deviation for the process. Now we have a process mean. Now we have our process with mean equals, oops, turn that back to, we have a process with mean equals 6.043 and standard deviation equals this sigma p. So this is the process standard deviation. And now we can find out what is the probability of a defect for a given product. It's a defect. So what is the defect for this example? So if we have a measurement greater than 6.047, which is our upper specification limit, or we have a measurement less than 6.039, which is our lower specification limit, we say this is a defect. So we say this is a defect. So what is the probability of a measurement greater than 6.47, and what is the probability of for measurement x is less than 6.039? How to find that? Excel has a function called normal distribution function. We can apply that function directly. So let's do the second one first. So this equals normal distribution st. So click the function button, you got this pop-up window. So this is our pop-up window. We want x be less than 6.039, so put 6.039 here, and the mean is 6.043. I just click that cell, and the standard deviation, I just click the standard deviation cell. Remember, the cumulative cell we always key in 1 here, which means it's true, and then we click OK. This is the probability of x smaller than 6.039, because the normal distribution function only returns a normal cumulative distribution for specific mean, and standard deviation x is the value for which you want the distribution, so it's only for x smaller than 6.039. So if you want to know the probability of x greater than 6.047, we need to use 1 subtract this our normal distribution. So this is going to be 6.047. Again, for the mean, I just click the mean. For standard deviation, I just click standard deviation. And remember, for the cumulative, it's always 1. It's always 1. So I click OK. And this is the probability of x greater than 6.047. Remember, if you want to use a normal distribution function in Excel to get the probability of x greater than a specific value, you need to always use 1 subtract this function. So for any value x greater than that, you need to always use 1 subtract this function in Excel. Alright, so the total probability of these two is this one plus this one. So the probability for a given product, is defect product, is going to be 0.07364. So this is our answer. This is our answer. For the home assignment 15.9, it says the probability the product has only minimum specification, so there's no upper specification limit. And what should this limit to take into account bias and precision and reject only 5% of the product? So if we know the probability equals 0.05 and we want to come back to find the value of x, what can we do is there is a function called normal inverse, INV, so normal inverse. Basically, you know the probability and you want to find what is the x value. Let's look at this window. So normal inverse, we know the probability is 0.06 and 0.05, 5%. We know the mean is here, and we know the standard deviation is here. If we click OK, so that number is 6.03932 inch. So this is how we use a normal inverse function to solve this problem. So by this, you should be able to finish problem 15.9. If you have any questions, just email me. Thank you.